Good morning, dear students. My name is Ferhan Mazher, and today is 30th March 2021. And we are studying the subject Physics 5054. It's O levels physics. And today we have set our hearts to solve October November 2012 2-1 paper. It's a theory paper, and in this session, we will be solving its section B. Section A of this paper, we will solve in another session, in another video. And let's start today's paper. So we are doing October, November 2012 to 1 section B. Okay, so the first question from the section B is question number 9. It says, a submarine is at rest deep beneath the surface of the sea. The gravitational field strength is 10 Newton per kg. The atmospheric pressure is 1 expo 5 Pascal, and the density of the seawater is 1 expo 3 kg per meter cube. Calculate the pressure due to the seawater at a depth of 120 meter. We can find the pressure of the water. The formula is very simple. The pressure of the water we can find by the formula rho GH. The formula is rho GH. Rho stands for the density. That will be in the kg per meter cube. It's given. G is the gravitational field strength. It is 10 Newton per kg. And H means the depth of the water. That is 120 meters. So just put these values in that formula and do the calculation, and you will find the pressure of the seawater. I have done this on a paper. Let me show you my work. And so hopefully this is visible on your screen. So the pressure of the water we can find out by the formula rho GH. The rho value is 1.0 expo 3, G value is 10, and the H value is 120. You just multiply them, and the final answer will be 1.2 expo 6 Pascal. Let's check from the marking scheme. If our answer is right, it's a 2 marks numerical. So the final answer is 1.2 expo 6 Pascal. So I hope you have understood this numerical. Very simple, 2 marks. Okay, the next question is the total pressure at the depth of the 120 meter. The total pressure at the depth of the 120 meter will be the pressure of the water plus the atmospheric pressure. So the total pressure will be equal to the pressure due to the water plus the atmospheric pressure. The value of the atmospheric pressure is given here, The atmospheric pressure, this is the value which is given. It is 1 expo 5 Pascal, and we just calculated in the A first part the pressure of the water. So we will add these two values and we will get the total pressure at the depth of 120 meter. So it's a 1 mark numerical. I have done this on a paper. Let me show you. So on your screen, you can see we have the total pressure will be equal to the pressure of the water plus the pressure of the atmosphere. Pressure of the water is 1.2 expo 6 plus 1.0 into expo 5, and final answer will be 1.3 expo 6 Pascal. So very simple. 1 mark, easy mark. You can secure easily this mark. Let me check the marking scheme. The final answer will be 1.3 expo 6 Pascal. Let's go to the next question. He says, let me show you this. Figure 9.1 shows a horizontal hatch. Hatch means a door, like this. Figure 9.1 shows a horizontal hatch of surface area 0.45 meters square on the top of the submarine. The hatch is at a depth of 120 meters beneath the surface of the sea. So the surface area of the hatch is given. Calculate the downward force acting on the surface of the hatch. We know the total pressure which is acting on the hatch at the depth of 120 meters. And we know the surface area of the hatch. So very easily we can find the force. The force, the pressure is equal to force divided by area. So if you want to find out the pressure, the force, it will be pressure multiply area. Pressure, we know the total pressure acting on the hatch at that depth. and we know the area of the hatch. You simply multiply the pressure with the area, you will get the force. I have done this on a paper. Let me show you. So here we go. So you can see that the pressure is equal to force divided by area. The force will be equal to pressure multiply area. The total pressure acting on the hatch at the depth of 120 meter is 1.3 x per 6 Pascal, and the area of the hatch is 0.45 meters square. To simply multiply them, the final answer will be 5.86 x per 5 Newton. Very simple numerical. Let me show you the marking scheme. Here you can see the marking scheme, and it says F is equals to P multiply A, and the final answer will be 5.8 x per 5 Newton. State two reasons why the force needed to lift the hatch is different from the value calculated in the first part. You know, when you will actually try to open the hatch, the force which you just calculated, which is trying to keep the hatch down, and the force which is required to open the hatch will be more than this. And he's asking you what can be the reasons why the force actually required will be different from the force which you just calculated. You see, when you try to open the hatch, one thing, you will have to open the hatch. So you will have to lift the weight of the hatch also. One thing can be this reason. Another thing can be because, you know, in the hatch we have hinge around which the hatch will be moving. So there might be, due to the sea water, there might be some corrosion, and there might be some friction in the ceilings of the hatch. So when you try to open the hatch, you will have to overcome that friction. So you will require more force, more energy to open the hatch. It's a 2-mark question. So let's check what I have written, and then we'll see the marking scheme. It says we have to lift the weight of the hatch. So when you try to open it, so we have to lift the weight of the hatch also. And another reason can be the friction in the hinge. So there might be friction in the hinge. So let's check the marking scheme. What the marking scheme says? Marking scheme says any two of weight of the hatch, pressure inside the submarine, friction at the seal, hinge or water resistance, and the lever effect. So you see, when you try to open it, the water will show resistance. So so these can be the reasons. You have to just name them. You don't have to explain. So the submarine uses, the question is, the submarine uses ultrasound to detect obstacles. State what is meant by the ultrasound. Ultrasounds are sound waves whose frequency is more than 20,000 hertz. This frequency, it is inaudible to human. Okay, because the audible frequency range is from 20 hertz to 20,000 hertz. So the ultrasounds are the sound waves whose frequency is more than 20,000 hertz. So these sound waves, the human are not able to hear. So they are inaudible. I've written this answer. Let me show you. Sound waves whose frequency is more than 20,000 hertz are called ultrasounds. These sound waves are inaudible to human. To say that it's inaudible to human is very important. Let me check the marking scheme. What the marking scheme says? Marking scheme says the sound or pressure waves and frequency is more than 20 kHz. Kilohertz means 20,000 hertz. And it's the beyond human hearing. They are inaudible to human. So I hope that you will be able to write the definition of the ultrasound. It's a 2-mark definition. The ultrasound is produced by vibrating source. Describe how the ultrasound is transmitted through the air. You see the source which produces the ultrasound, it's vibrating. It's vibrating from its mean position to and fro. It's vibrating about uh, or to and fro about the mean position. So what happens when it moves forward? It produces compression in the air. And when it moves backward from its mean position, it produces rarefaction in the air. So the particles of the air which are adjacent to this vibrating source, they uh, collide with their neighboring molecules and they pass on their vibration to their neighbors. So you see this vibrating source, when it keep on vibrating, it produces compressions and rarefaction. So the vibrations and the rarefactions, they are passed on to the adjacent air molecules and they pass this to their neighboring molecules. So in this way, in the air, the compressions and rarefactions are produced and the air molecules vibrate and they vibrate parallel to the direction of the wave. So in this way, the ultrasounds are produced in the air also. It's a 3-mark question, very important. You see, let me first of all see what I have written as an answer. Then we will see what the marking scheme says. So the vibrating source make air molecules vibrate. Air molecules make their neighbors vibrate in the same pattern by colliding with them. So vibrating energy is transferred from molecule to molecule. So compressions and rarefactions are passed on through air molecules. So let's check the marking scheme. What the marking scheme says, what should the answer should look like. He says the water molecules, particles vibrate, oscillate. Molecules collide with the other molecules or neighbors, pass on vibration energy to the neighbors, or longitudinal vibration waves or compressions and rarefaction. So it's a 3-mark question. So I hope that you will be able to write. I by chance has written there air, but in real, the question was about water. So instead of saying air, use the word water. So the answer which I wrote, I used the word air. Vibrating source make water molecules vibrate. Water molecules make their neighbors vibrate in the same pattern by colliding with them. So vibrating energy is transferred from molecule to molecule. So compression and rarefaction are passed on through water molecules. So wherever I wrote the air word, the word air, you write water. It's a 3-mark question. An ultrasound pulse is emitted at a later time. The reflected pulse is detected. The time between the emission and the detection of the pulse is t. State the other quantity that must be known in order to determine the distance of the obstacle from the submarine. You see, if you want to find out the distance, if you know the how much time the ultrasound took from the submarine to go to an obstacle and then come back, if you know that time, and another thing, if you know the speed, then very easily you can find out the speed of the ultrasound in the water. This another thing which you should know is the speed of the ultrasound in the water. If you know that, we can find the distance between the submarine and the obstacle. The second part is state how the distance of the obstacle from the submarine is calculated. You see, we know the time t which the ultrasound took from going to the obstacle and then from coming back to the ship. So this is the time in which the ultrasound went to the obstacle and came back. So simply multiply the speed of the ultrasound with the time and then divide their product with 2. And why we do this? Because this involves, because when you multiply with speed with this time, it will give you the total distance. The ultrasound went and came back. So it is telling you the total distance covered by the ultrasound. But the question is how you calculate the distance between the obstacle and a submarine. That will be the half of this distance. So you multiply the time with the speed of the ultrasound, and whatever the answer comes, you divide it with 2. Very important. His fourth part is state one other use of the ultrasound. You see, another use of the ultrasound is that the ultrasounds are used for the prenatal scanning. Prenatal scanning. Let me show you my answers. I have written my answers. So here we go. Speed of the ultrasound, that was the first part. Multiply the speed with time, divide the product with 2, and you will have the distance of the obstacle from the submarine. And the next one is ultrasound is used for the prenatal scanning. Another use of the ultrasound is it is used for the cleaning of the jewelry. Okay. So, my dear students, we are done with the question number 9. I hope that you will be able to solve it. You will be able to write its answer in your notebooks. Uh, the best way of studying with these YouTube videos is that you should have a hard copy of this paper and you write it on the paper. Okay. And this is the best way of learning. Okay, so question number 10, figure 10.1 shows a domestic heater that is used to heat a room. It contains 16 large bricks, each of mass 75. So how many bricks are there? There are 16 large bricks and each has a mass of 7.5 kg. So there are 6 bricks and each brick is of 7.5 kg. So his question is, during the night, the bricks are heated from a temperature of 17 degrees centigrade to 96 degrees centigrade. The bricks are made from a material that has a specific heat capacity of 2300 joules per kg per degree centigrade. Calculate the thermal energy heat supplied to the bricks. You see here the temperature change is involved. So we can find out the amount of heat required. The heat is equal to mc delta theta. Heat is equal to mc delta theta, where m stands for the mass, the total mass of the bricks, c stands for the specific heat capacity of the bricks, and the delta theta means change in the temperature. So the change in the temperature you can find, you see the initial temperature is 17, the final temperature is 96. So 96 minus 17, it will give you the change in the temperature. The C value is 2300 joules per kg per degree centigrade. And the mass of the bricks will be, there are 6 bricks and each brick is of 7.5 kg. So you multiply 6 with the 7.5. I've done this on a paper. It's a 3-mark numerical. So question number 10 is showing on your screen. 10A part, heat is equals to mc delta theta. 16 multiply 7.5 multiply 16 multiply 7.5 multiply 2300 multiply 96 minus 17. So the change in the temperature will be 79. So 16 multiply 7.5 multiply 2300 multiply 79. So it will be like 21804,000. 2.2 x plus 7 joules. 1, 2, 3, 4, 5, 6, 7. So it will be like 2.2 x plus 7 joules is the energy which is required. So let me check the question once again. So how many bricks were there? I have 16 bricks were there. Okay. So I hope you have understood this. Let us check the marking scheme also. So our answer is right. 2.2 x plus 7 joules is the right answer. And you can have a look at the marking scheme also. Question number 10A part. So very easy question. During the day, the bricks gradually cool and the stored thermal energy is released to the room. After 7 hours, the bricks have cooled to the 17 degrees centigrade. So the bricks from 17 degrees centigrade, first they went to 96 degrees centigrade, and now they are cooling down, and now they are back to 17 degrees centigrade. And this happened in 7 hours. Calculate the average rate of release of the thermal energy to the room during these 7 hours. So the same amount of energy which we just calculated, that was required to raise the temperature from 17 degrees centigrade to 96 degrees centigrade. The same energy will be released when the bricks will cool from 96 degrees centigrade back to 17 degrees centigrade. So the same thermal energy I will use, and I know the time duration, that is 7 hours. The time is 7 hours, and I want to find out the average rate of release of thermal energy. So the rate of release of thermal energy means rate of energy, that is called power. So the power is equal to the energy divided by time, but the time must be taken in seconds. Here the 7 hour time is given, so I will convert it into seconds. So how you convert hours into second? You multiply it with 36. You multiply it with 3600. So the hours will be converted into seconds. So let me show you my work. It's a 2 mark numerical. I have done this. So the rate of thermal energy will be equals to the energy or thermal energy divided by the time. The thermal energy is 2.2 x plus 7 joules, and the time is 7 hours, which means in seconds 7 multiplied 3600, and the final answer will be 865.26 watt. So you can say 870 watt. Hopefully it's clear to you. Let me check the marking scheme. So here you can see 870 joules per second, or watt is the right answer. Okay, so let's move to the next question. At the beginning of the day, the heater releases thermal energy at a greater rate than later in the day. Suggest why. You see, it's a 2 mark question, and the thing is very interesting. You see, the bricks are at 96 degrees centigrade when the day starts, and then it starts cooling. So the rate of cooling in the start is very fast. In the beginning of the day, the rate of cooling is very fast. But as the day becomes during the day, the rate of cooling becomes less. The rate of loss of the thermal energy becomes smaller. So later in the day, the rate of the loss of the thermal energy or release of the thermal energy becomes smaller. The question is why. So we have to suggest why. You see, whenever you have a hot body and it's in cold surrounding, so it will lose its thermal energy. So the body is hot, the surrounding is cold, so it will lose its thermal energy. So the rate of the thermal energy depends upon the difference of the temperature between the hot body and the surrounding. So you see, in the start of the day, in the beginning of the day, the bricks are at 96 degrees centigrade, and whatever is the room temperature. So the temperature difference between the brick and the room temperature will be quite large. We say temperature gradient. The temperature gradient will be larger. Means the difference between the bricks, they will be hot, very hot, and the temperature of the surrounding, the difference between them will be large. When the difference between the hot body and the cold surrounding is larger, the rate of the loss of the thermal energy is also very fast. But as the bricks lose their thermal energy, their temperature drops. And later in the day, you see what happens, the difference between the temperature of the bricks and the surrounding, that difference becomes smaller. So when the difference between the temperature of the hot body and the cold surrounding becomes smaller, then the rate of the thermal energy loss also becomes smaller. So this is the reason. So it's a very simple explanation. It's a 2-mark explanation. I've written this answer. Let me show you my answer. And here on your screen, you can see at the beginning of the day, the temperature difference between bricks and room is larger. So rate of heat loss is greater as compared to the rate of heat loss later in the day when the temperature difference decreases between the bricks and the room. So when the temperature difference between the bricks and the room is smaller, the rate of thermal energy loss is also small. So I hope you have understood this. Let me check the marking scheme, what the marking scheme says. So he says that the heater bricks hotter, not room cooler, greater temperature difference between heater and the room. So I hope that you will be able to write whatever the answer I give. Just write that answer. It's perfect. Now, he says figure 10.2 is a diagram of heater standing on the floor of the room and placed next to one of the walls. Describe and explain in detail how the thermal energy is transferred throughout the room. You may draw on the figure 10.2. You see, very simple. In the room, because it's a heater, and from the heater, the heat is given to in the room by 2 methods. So the first one is by the convection of the air. You see what happens? The air molecules which are near this heater, they absorb the thermal energy and they move away from each other. So the air which is adjacent to the heater, it becomes less dense. And this hot and less dense air rises upward. So here a low pressure is created. So on the top, the cold and the dense air that will sink and it will come here, and the hot air will rise upward and the cold air will sink. So in this way, in the room, convection currents are set up. The convection currents start circulating, and by the help of the convection currents, the heat is distributed throughout the room. Another method by which the heater gives heat to the whole room is by the emission of infrared rays. So from the hot heater, the infrared rays are also given out, and they also transfer energy. So it's a 5-mark question. Let me show you the whole thing. It's a big question. Look at here. It has 5 marks. Let me show you my answer. I've written this answer. So here you can see he asked us to draw the diagram. So the air which is near the heater, it will become hot and it will rise upward. And the cold and the dense air from the top will sink here. And it will come here because here a low pressure will be created. So the air will suck in. And from here it becomes hot and it goes up. So dense air is sinking and the less dense air, hot air, is rising upward. In this way, you can see the convection currents start circulating in the room, and by the convection currents, the heat is distributed throughout the room. He says, air near heater absorb heat. Air molecules move away from each other. Air becomes less dense. Less dense air rises up. Cold, dense air sinks. This sets up convection currents in room. So by convection, heat is distributed in the room. Heat is also distributed by, let me show you, by, okay, so I think I have cut by the infrared radiation. So I have just cut it. So let me check the marking scheme. You see, it's a 5-mark question. He says 1 mark is for saying that the air next to the heater gets hot or conduction through the metal casing, 1 mark for telling this thing. Expands or radiation or IR radiation, 1 mark for the infrared radiation. And 1 mark is for telling that the air will become less dense. And 1 mark is for telling that this less dense air will rise upward. And 1 mark is for telling that the circulation or convection currents or arrows on the figure 10.2. So now I hope that you will be able to write this answer, and you will secure full 5 marks out of this. So the next question is B part. State one method of thermal insulation that is used to keep a room warm and explain why it is effective. For example, there are many ways by which, if you are in a cold climate and if you want to keep the room hot, so there can be many methods. One method is we put carpets on the floor because the heat is absorbed by the ground, cold ground. So if you will put a carpet on the floor, so the carpet has fibers, it has trapped air in it, which is a bad conductor of heat. So the carpet will not let the heat absorbed by the ground. Another method can be the walls should be cavity walls, and means two layered wall, and between the two layers we have cavity, and in that cavity we fill some insulation. So when you have used double walls with the means the cavity, and you have filled in that cavity insulations, so what will happen, the heat cannot be lost to the surrounding by the conduction and the convection, because that cavity wall will stop the conduction and it will also stop the convection. So it's a 3 mark question. Let me show you my answer first of all, and then we will see what we have. The walls of the room. The wall of the room can be cavity walls. Cavity can be filled by insulating material. This will stop heat transfer by conduction and convection. Let me check the. Okay. So you can see the D part, its marking scheme is coming on your screen. He says double glazing, and glazing means the walls should be very shiny. Cavity walls means the walls, and we have a gap between the two layers of the wall. And ceiling, we also do the ceiling, the false ceiling which we do in the rooms. And the tiles, carpet, curtains, loft, insulation, etc. traps air. Air is poor conductor, convection prevented. Shiny foil, if you talked about the shiny foil or glazing, and the shiny foil radiation reflected IR radiation back into the room. So I hope that you have understood this, and you will be able to write one way, and also explain that how this will prevent the heat loss. State here in this question, we have to state one method, and then you have to explain. Only you have to mention only one method, and then you have to explain that how it will stop the loss of the heat. So it's a 3 mark question. So my dear students, by the grace of the God, we are done with the question number 10. Now we are moving to the question number 11. Figure 11.1 shows the thunder cloud with a flat positively charged base. It passes over a tall tree growing in a region of flat open land. So you see here you can see, let me show thing. Here we have a cloud, and the bottom of the cloud is positively charged, and here I have a tree on the ground. So the question is, on the figure 11.1, mark the charge on the tree. So due to this bottom of the cloud, this positively charged bottom of the cloud, the electrons will be attracted towards this positive charge. So the electron will come on the top of the tree. So here on the top of the tree, we will have negative charge because those negative electrons, they are being attracted by this positive bottom of the cloud. So it's a 1 mark question, and the second part is of 2 marks. He says explain how the tree becomes charged. So all the electrons in this tree, they are being attracted by this positive charge on the bottom of the cloud. So due to this electrostatic force of attraction, the electrons will be accumulated on the top of the tree. So the top of the tree will become negatively charged. It's a 2 marks question. And let me first of all show you my answer. So on your screen, you can see that here I have shown that the top of the tree will become negative because this bottom of the cloud is positive. And why this is happening? Due to the positive bottom of the cloud, the electrons are attracted. So the electrons move to the top of the tree. So hopefully you will be able to write this answer as well and make this diagram. Let me read it from the marking scheme. Marking scheme says that the correct negative charge on the tree, 1 mark is for this. The second part is the electrons or negative charges attracted by the cloud's positive charges. Electrons from the ground or correct induction mentioned. So you see, due to the presence of the positive charge, the electrons in the tree, they will be attracted to the top, and that's why the top of the tree will become negatively charged. 2 mark question. The next question is, he says the lightning strike occurs and 2 expo minus 4 seconds. In 2 expo minus 4 seconds, a charge of 560 coulomb passes from the cloud to the tree. The size of the charge on an electron is 1.6 expo minus 19 coulomb. Calculate the number of the electrons that pass between the tree and the cloud. We know the charge which flowed. That's 560 coulomb. And we know the charge on a single electron. We know the charge on a single electron, and we also know the total charge. So divide this amount of charge with the charge on a single electron, and you will get the number of electrons involved. So let me show you my work. I've done this. So here you see question number 11a, second part. 560 coulomb is the charge, and the charge on a single electron is 1.6 expo minus 19 coulomb. So on your calculator, write 560 divided 1.6 expo minus 19 equals to. So the final answer will be 3.50 expo 21. 3.50 expo 21 number of electrons will be present there. So let me check the marking scheme if our answers are right. So you can see here 3.5 expo 21. Our answer is 3.5 expo 21. So we are right. So it's a 2 marks numerical. I hope very easy. You have understood this. I have the total charge and I know the charge on a single electron. So just divide the total charge with the charge on a single electron and you will get the total number of charges there. It's a 2 marks numerical. Very simple. Then it says calculate the average current in the lightning strike. We can calculate the current. Current is charge divided by time. I know the amount of charge and I also know the amount of time. The time is 2 expo minus 4 seconds. And the amount of charge which flowed is 560 coulomb. So simply divide the charge with the time and you will get the amount of current. I is equals to Q divided by T. I is equals to Q divided by T. So we will have the Q value is 560 coulomb and the time is 2 expo minus 4. So on your calculator, you will write 560 divided by 2 expo minus 4 equals to, and the final answer will be 2.8 expo 6 ampere. I've done this on a paper. Yeah, on your screen now it's showing. So at the bottom of this tab, you can see, and the I is equals to Q divided by T. That's 560 divided by 2 x power minus 4. And the final answer will be 2.8 x power 6 ampere. This 10 raised power 6 means mega. So it is like 2.8 mega ampere. So let me check the marking scheme so you can have 100% surety that everything is good. So you can see that number of electrons 3.5 x per 21 and the amount of current is 2.8 x per 6 ampere. The next part is two now two flat metal plates are positioned horizontally, one above the other. Figure 11.2 shows the positive terminal of a high voltage supply unit connected to the bottom plate and the negative terminal connected to the top plate. So this top plate is like negative and the bottom plate is positive. The high voltage supply is switched on. Figure 11.2, draw the shape and the direction of the electric field produced. So the electric field, is always from positive to negative. So I have done this, I have drawn this. Let me show you my work. Okay, so here you see this lower plate is positive because it's connected with the positive terminal of the battery. The top plate is negative because it is connected with the negative terminal of the battery. And the electric field is always from positive to negative. So between these parallel plates, the electric field lines, they will be uniform. But on the ends of these plates, they will be little bended outward. Okay, so they will be bended. But in the middle, they are equally spaced and they are uniform throughout. But on the end, you can see we have to show the electric field lines with little bends. Electric field lines always start from the positive and they go to the negative. So don't forget this. Okay, never forget this idea. So he says, B first part, at least 4 vertical lines between plates, equally spaced or curved at the edges. This is very important. It should be curved at the edges, arrows positive to negative, upward. So hope you have understood this diagram. Let me move to the next question. Suggest why a small charged oil droplet placed between the two metal plates accelerates upward. So what they have done, they have placed an oil drop here and it moved upward. Against the gravity, it went upward. So why will this happen? Why an oil droplet moves against the gravity? That's how this is possible. The reason is because the droplet is positively charged. And the positive charge particles, they will move along the electric field. So if the electric field is from positive to negative, I mean in upward direction, when you put a oil drop here, the oil drop is, I think, also positively charged. So it's repelled from this positive plate. It is attracted by the upper negative plate. So what happened? It is influenced by the by the, what we call this, electrostatic force of attraction and force of repulsion. So there is gravity also acting on the droplet. The gravity is trying to stop the droplet, but the droplet will move against the gravity and it will move upward. This is happening because of the electrostatic force of attraction and repulsion. So I have written this answer. It's a 3-mark question, very important. So let me show you my answer. Increase the size. Oil droplet moves upward against gravitational pull. oil droplet is positively charged, it is repelled by positive plate and attracted by a negative plate. So upward force is greater than the downward force. Resultant force is in the upward direction. You see the upward force, which is electrostatic force of attraction. This value is greater than the weight of the droplet, which is acting downward. So the upward force is greater in the magnitude as compared to the downward weight. So the resultant force will be in the upward direction, and that's why the oil droplet will move upward. So I hope you have understood this. Let me show you the answer. He says the droplet becomes, the oil droplet positively charged, attraction force on the droplet and in the direction of the field means upward, force greater than weight of the droplet or resultant force. So there is a resultant force in the upward direction. The electrostatic force of repulsion and attraction is stronger than the gravitational field. The oil droplet touches the top metal plate. State and explain what happens to the charge on the oil. You see this. If I have a positively charged droplet, it will move upward, and when it will touch the negative plate, so what will happen, because the droplet is positively charged, it will uh, it will accept electrons and it will become neutral. Let me read my answer and then we will see what you have. Okay. Oil droplet will gain electrons and will become negative. It will gain electrons first, it will become neutral, then it will become negative. So by this question, we have reached the end of the paper. Let me check the marking scheme. The droplet will becomes negative, droplet gains electrons. So when it touches that top plate which was negative, it will become negative also. So So, my dear students, by this question, I think we have reached the end of the paper. So, in this paper, and we have done today, we have done October, November 2012, Physics 505421, and section B of this paper we have done. In the section we have done question number 9, question number 10, question number 11. I have also written the answer of these questions, and we have also checked the marking scheme. I believe that you can write better answers. My students can write better answers. So that's why it's very important that you listen carefully the description which I give you, and then you check out what the answer I have written, and that is not the final answers. You can write better answers. Then you check the marking scheme, and then you write your answer. Hopefully this whole thing is helpful to you, and this will bring a lot of uh, I mean the it will be it will bring lots of benefit to you, and it will become easy for you to understand the physics and practice the past paper questions. My dear students, if this whole thing is helpful to you, if this video is helpful to you, if this is helping you to improve your concepts of physics and attempt the paper 2 of the physics, if you think it's helpful to you, kindly recommend this channel to your friends. Also, don't forget to subscribe my channel. Don't forget to ask your friends to subscribe my channel, and always press the like buttons, because when you support me by subscribing and by sending likes and by sending comments, it gives me energy, and I will work more and more, and I will work harder and harder. I will bring better answers in a better way. So thank you very much, everybody. Have a good day, and God bless you all. So thank you very much.